Good morning, everyone. I'm Mohammad Afshan, a third year student from Department of Computer Science Engineering with specialization in cybersecurity at Saveetha Engineering College. I'm presenting my mini project titled AI Driven Autonomous and Adaptive Firewall. This project is carried out by myself, Ragul Rajan, and Ravi Varman under the guidance of Dr. Hema Darshana S. This project focuses on how artificial intelligence is used to automatically detect, learn, and respond to cyber attacks in real time. So, the traditional firewalls mainly depend on static rules and manual updates. These systems are not effective against the modern attacks like the DDoS, SQL injection, and cross-site scripting. To explain simply for a non-technical user, imagine a security guard who follows only an old notebook. If a new type of criminal appears, the guard will not recognize it. In the same way, the traditional firewalls fail against the new and evolving attack patterns. Hence, the problem is to design a firewall that can automatically learn and adapt without human intervention. So the main objective of the project is to design an AI-driven firewall system that can detect the network layer and application layer, automatically block malicious traffic, provide real-time monitoring through a dashboard. The scope of this project includes AI-based NIDS, Network Intrusion and Detection System, and WAF, Web Application Firewall, and Autonomous Mitigation. But it does not replace full-scale SIEM systems. So, the target audience for the system includes the critical infrastructure such as power grids and hospital and enterprises like banking and cloud platforms, and especially the government and defense network where the real-time protection is very critical. So the methodology is used. The project follows a 6-step methodology. Data collection. The data collection is nothing but the data sets are collected, and there are some of data sets which are benign traffic and attack traffic. Second one, the data pre-processing. So it's nothing but the cleaning and the feature extraction and the model training. ML, machine learning, is used for NIDS, and convolutional neural network is used for web application firewall. So the web application development, the fourth one, the web application development, which is monitoring the dashboard. So it shows the live tracking of packets. So next, the integration with agents, models, and dashboard. And last one is testing and evaluation using simulated and live attacks. So this structured approach ensures accuracy, scalability, and real-time performance. And the dataset we used here are public datasets such as CIC IDS 2017 or the NSL KDD datasets, and we have used a curated payloads for SQL injection and cross-site scripting. So these datasets help the model learn both normal behavior and attack patterns. So here's the architecture diagram of the project. So there are 3 devices, such as the attack zone, AI-driven firewall zone, and the victim zone. So let us mainly focus on the firewall zone. So the firewall has 3 main components: the agent, firewall virtual machine, and the dashboard backend server is viewed at the victim zone, or at where the admin monitors the traffic, and the web-based front-end dashboard. So the network traffic first reaches from the attacker to the agent in the firewall. Then the decisions are sent to the back end, and the results are shown in the dashboard whether it is a benign packet or it's a malicious packet. So what it does, it moves to the, if it's a malicious packet, it triggers the mitigation engine, and the IP blocks the list, and it saves in the log file. But and what happens is, if another IP packet, malicious packet, arises from the same IP, the firewall automatically detects it and blocks it. So here is the UML diagrams. The first one is a use case UML diagram. The use case UML diagram shows how different persons can interact with different things. So for example, the system administrator can monitor the real-time packet stream, view live attack dashboard, and configure the deployment mode. And for example, the attacker can launch the attack, and the victim can send benign traffic, and the agent can intercept the live traffic using NFQUEUE. So the class diagram explains the internal structure like the packet analyzer, ML model, and the firewall controller. Next, the sequence diagram shows how the real-time flow, packet flow, like example, the packet capture, analysis, decision, and dashboard update. So, the project uses the following algorithms. One-dimensional convolutional networks. It works by encoding payloads into numerical form, extracting malicious pattern using convolutional filters, and classifying attacks such as SQL injection and cross-site scripting. This allows fast and accurate real-time detection. So, the hardware we implemented in this project is the Linux system or virtual machine, and the software we used is Python, Flask, TensorFlow, PyTorch, and NFQUEUE and ipset. These tools support real-time packet inspection and blocking. And for tracking the packets, we used Python's Scapy tracer. So these are the main important files of a project. The SAS enforcer.py. This file SAS enforcer.py runs inside the firewall virtual machine. It inspects each packet and decides whether to allow or drop or to send to the NFQUEUE. Each packet decision is sent to a JSON post request to the dashboard backend, including the source IP address, destination IP address, verdict, and observer agent IP. For a non-technical understanding, this agent acts like a smart security gatekeeper. So the next is our main.py. The main.py files handle the backend logic. It receives the packet from the agent and broadcasts it to browsers using WebSockets. So it have the live packet end stream and traffic statistics and reset functionality. So this ensure real-time update without the page refresh. And data sets are trained separately for for a packet inspection. The data sets are trained using the train NIDS.py, and for SQL packets, like for training, we have used train WAF.py. And the output dashboard shows the live packet stream and allow and drop verdicts and attacker alerts using color codes. So our machine learning model detects around 90% detection and effective blocking of SQL injection and DDoS system. So real time, it will be a real time visibility for administrators. So let me execute the project. So there is a small, like we have combined all the commands into a small bash script, and we are going to run the project. So as you can see that we have the machine ML engine is running on the port 5001, and the dashboard is running on the local host on the port number 8000. So let us view the output. So this is our dashboard. As you can see that the live time is 8:29 and the live time here is also 8:29, and it also shows the source address and IP address 192.168.1.10, and it says what type of protocol is used and the packet length, and it also shows the verdict whether it is allowed or dropped, and it also says that total attacks block 8 and safe request are 4, and the total packets scanned is 175. So the even this color indication also says about the project that this is there are some suspicious packets and some benign packets. So that's all. So in conclusion, this project demonstrates how AI-driven autonomous firewall can improve cybersecurity by reducing manual intervention. This system is capable of learning, adapting, and responding to modern cyber threats in real time. So in our future, the system can be enhanced by using advanced deep learning models, centralized cloud dashboards, encrypted traffic analysis. This will make the firewall more scalable and enterprise ready. So thank you all for giving me this opportunity, and have a great day.